All right, everybody, welcome back. We're going to go on to part 3 now using normal curves, and what we're going to be doing now is changing from percentiles into scores, whereas last time we did scores into percentiles. So we're going to use the same model here for IQ scores of the means 100 and the standard deviation is 15. So I'm going to go ahead and draw my normal curve like we were doing before. So here's my normal curve sketch. My mean's at 100. I write in normal 100 comma 15 to illustrate which curve I'm using here. First quartile, we know that's the lowest 25th percentile. That would be over here, so the lowest 25% of the curve is over here. We'll go ahead and write 25%, and the dilemma is this time we don't know what the score is. Where before we knew the score but didn't know the percentage, now it's reversed. So using our formula of z equals x minus mu over sigma, we get z equals x we don't know, mu is 100, and our standard deviation is 15. So now the question is, if we're solving for x, how do we know what z is? If we knew what that was, we're in business, because then we could go ahead and solve and cross multiply and all that kind of stuff here. In fact, I can put that over 1 right now. So this is how we're going to find this. To find the z score for that amount, we're going to use a function on your calculator called inverse norm. And we're going to do it of 25% because that's the 25 percentile that we're looking at over there. So go ahead and grab your calculator. I'm going to go and clear mine out. How do you find inverse norm? It's second vars, and it's actually number 3 on the list. So I'm going to go ahead and click on number 3. Bam. So what do we have here? We have 0.25. We're going to use a mean of 0 and a standard deviation of 1 for now, and go on down to paste. Press enter again, and so what comes out, inverse norm, it tells us what the actual z-score is. So the z-score for here is negative 0.6745. And if we go ahead now and actually cross multiply, once again going back to the calculator here, I'm going to take my answer, I'm going to multiply by 15, so times 15, enter. So I get negative 10.1. So negative 10.1 equals, and 1 times this is x minus 100. And if I go ahead and add 100, I'm going to get 89.9 equals x, or it's about 90. So about 90 would be the first quartile. Alright, and there's another way you can do this exact same calculation that saves you some time. So going back once again to inverse norm, instead of doing 0 and 1, you can actually change it so that you use the mu and the standard deviation of the actual question. So mu was 100, and our standard deviation, sigma, was 15. Go down to paste. Go ahead and enter it, and you actually get the exact same answer we did before, so about 89.9, and then go ahead and round it off. So that's kind of a super secret shortcut here. Alright, we're going to go on to another problem here. This is problem number 2, and it says what score represents the best 20%? Once again, we always draw a sketch. Go ahead, draw a normal curve. Here's my normal curve. My mu is 100. It's a normal curve of 100 comma 15. The best 20% would be over here somewhere. There's my 20%, and I don't know what x is. So we're going to go over here, and we're going to go ahead and do our formula up here. So z is x minus 100 over 15. Now, how do you actually find this? Now, the people will be tempted. Obviously, you're going to use inverse norm because that's how you find z-scores. But you're going to be tempted right now to actually use 0.20 because it's the upper 20%. But let's take a look, and I'll show you why that actually does not make sense. So second vars number 3, if you were to go ahead and enter in 0.20, and I'm going to go back and switch it to 0 and 1 here, if you go ahead and actually calculate that, you get a z-score of a negative number. And obviously mu has a z-score of 0, and anything above it has a z-score of a positive number. So therefore, when we're looking at this right here, this can't be. It can't be a negative, it has to be a positive z-score. So we're not going to use 0.2, and the reason why is your calculator doesn't look at the upper 20%, it actually looks at the other part of the curve because it always thinks from left to right. So we're actually going to look at the 80% going here from left to right. Just like here we looked at 25% left to right, here we're looking at 80%. So we're actually going to use 0.80. So when you do that, what we're going to get instead this time is second vars number 3. We're going to use 0.80. Go ahead, go down to paste. Press enter. So it's actually 0.842, which is the opposite version of that. So 0.842. Now, once again, if we're going to go ahead and do this here, let's go ahead and use the super secret shortcut way. So second vars, let's use 0.80 and change this over to 100. And change our mu over to 15. Let's let the calculator do the work for us so we don't actually have to do it. And the answer ends up being pretty close to 113. So over here I'm going to write down x equals 112.62, which is roughly about 113. So that would be the best 20% of scores, 113 and higher. Finally, the last one we're going to do here is question number 3, and we're changing it up here. So it says, suppose you want to create a new IQ scale in which no more than 20% of all IQ scores can be below 80. You're going to keep the standard deviation at 15, but you're going to change the mean to something else. So if we drew a picture, go ahead now, draw your normal curve, and in this situation here, we don't know the mean, but we know the standard deviation is 15. We know the bottom 20%, is 80, and that's our x value over here. So when we do our actual equation over here, we actually do know x this time, excuse me there, we do know x. We don't know mu this time, and we know our standard deviation is still 15. So to get this here, we're going to have to do inverse norm. So if we were to go ahead and do inverse norm of 0.20, what would happen here is we would go ahead second vars inverse norm. We're going to use 0.20. By the way, you can't use this super secret shortcut here, so change it back to 0 and 1. Go ahead and paste. So it is negative 0.842. So negative 0.842 over 1 equals 80 minus mu over 15. Now when you go ahead and solve this here, grab the calculator, go ahead and take that answer, multiply by 15, because that was our standard deviation when we're cross multiplying here. So we get negative 12.6. So we just did this calculation here. So negative 12.6 equals, now we go this way, we get 80 minus mu. And when you go ahead and add mu and then add 12.6, you get 92.6, or roughly 93. So that would be our new mu calculation. That's it.